So we're going to spend the rest of the week on this section. We're going to talk about today is mostly stuff that you've done before. So systems of linear equations. So when I talk about that, just a few things to kind of jot down, make sure you know what I'm referring to. When I ask for a solution, it makes both equations true. So a system can be two or more equations. The solution has to make every single one of those equations true. If you get a solution, that's what we call a consistent system. If it has no solution, we call it inconsistent. And you will have to know that as we go through these. Anytime we get no solution, you will have to say inconsistent along with that. What I want to mention just on the graphs, when I'm talking about consistent, that would be something like this, where I give you two lines and they meet at a point. This is consistent because they have a solution. What is the solution to this system?
2, 1.
2, 1. That's the point where they meet. What would inconsistent look like?
They don't.
Two lines that never meet, and the only way they would not meet is if those lines are parallel. Pretend those are parallel. So that would be no solution, and on that we would say no solution, inconsistent. I want you to identify those.
Can we know like right off the bat?
If you're looking at a graph, yes, you'll know if you see them. Most of the time we won't look at a graph, only because graphs are really only helpful if the solutions are nice and pretty. So we'll talk about how to do it algebraically, and it's probably a little less obvious that way. Okay, so if we have a graph, it's easy. We just look at where they meet. If we don't, then the two techniques we're going to discuss are substitution and elimination. Do those ring a bell?
Yep.
All right, so let's do a substitution. I do want you to know both methods. So like on a test, I might say do this one by substitution and do this one by elimination, just making sure you know both ways. So substitution involves taking an equation, solving for a variable, and substituting into the other one. Now, it does not matter which equation and which variable you start with. So, what do you want to do?
I already forgot the 2 things.
So, pick an equation.
X plus y.
All right. Let's say I wanted to solve for x. So, if I want to get x by itself, x would be 8 minus y. Then you substitute that into the second one. So in the second equation, we start with x, but x is 8 minus y. Minus y equals 4. Negative y and negative y is negative 2y. Subtract over the 8. Divide by negative 2. So we get y equals 2. Now that's not my final solution.
Then you have to bring it back up to 8 minus 2.
So we already said x was 8 minus y. So then 8 minus 2 is 6. So final answer, I want an or pair x, y. So 6, 2. And this is easy to check. 6 plus 2 is 8, 6 minus 2 is 4. It has to make both equations true. Is that one okay? Do we need to do another substitution example?
No.
We're just doing.
Nope.
Yeah, we'll do one more substitution, then we'll do elimination.
I'm sorry.
See, I was prepared. I was planning to do one more. So it doesn't matter which equation and which variable, but sometimes there is an easier path. Which would be the easiest thing to solve for on this?
Why?
Yeah, solve for y in the first equation, because that way we avoid fractions. Now, does that mean you have to do it? No, but it's just going to be a little bit easier. So y would be 5 minus 2x. And then you have to substitute that into the second equation. So negative 4x plus 30 minus 12x equals negative 2. Negative 4x and negative 12x is negative 16x. Subtract over the 30. Divide by negative 16. And get positive 2. So then plug that back in. Y is 5 minus 2 times 2. So 5 minus 4 is 1. So my final answer, xy, would be 2 comma 1. And we can check 2 times 2 plus 1 is 5. Negative 4 times 2 is negative 8. Plus 6 is negative 2. So it works. All right. In the second option, elimination, what you have to do is multiply one or both of the equations by something so that when you add them together, one of your variables gets eliminated. So you have to start by picking which variable you want to eliminate. Again, it's not a right or a wrong. You can do either way. Sometimes one is easier than the other. Okay, we want to eliminate x.
Multiply
So
everything by 2.
if you multiply the top one by 2, they have to be the same number but opposite signs. So if we multiply by 2, we'd have a positive 4x and a negative 4x, so they would cancel. Okay. So that's what we're going to do. This first one times 2. If you had wanted to eliminate y, what would you have done? Negative 6. Good. So then we add the two equations together. So positive 4x and negative 4x cancel. 2y plus 6y is 8y. And that's a 22. Divided by 8. So it's okay to get decimals or fractions. You don't have to have only nice, pretty answers. Once I have that, how do I get x? Does it matter which equation? No, if you pick one of them, we plug in our y, and we're going to solve for x. So I put it in the first one. So if I subtract that 11/4, 5 minus 11/4, 9/4, divide by 2, and get 9/8. So my answer is 9/8, 11/4. And if you wanted to check it, what do? Plug it into both equations and make sure it works. So all of these equations have been consistent. All of them gave us a solution. Are we doing okay so far? Okay. Let's say I gave you, let's do, set up a little bit differently, but we can still work with this. Let's do elimination. Which variable do you want to eliminate?
Why?
Okay. So we have a -6 and a +4. What can I turn both of those into? 24, 12. Is there a right or a wrong? No. You could, if you were going with the x's, you could turn them into 15. So let's say if I wanted to get 12, I could take this one times 2, and I'd have to multiply this one by 3. And it's okay if you have to do both equations like that.
But would it both be negative? Oh wait, no, negative.
Yeah. But if they were the same sign, you just multiply one of them by a negative number. So if I have those together, we get 21x minus 7 equals 0. So we can add over the 7, divide by 21, so x is 1/3. So now we have to find y. So we can plug it back into either equation. Let's just go with the first one. So 3 times 1/3 is 1. 1 minus 2 is -1. So 1/3 -1/6. Sorry. So far, so good? Do you guys remember a lot of this?
Yes.
Yeah.
Okay. Then I want to do maybe 2 more examples and then I'll be done. Okay? Unless we need more than that. Okay, so if I asked you to solve this one, you can pick substitution or elimination. What would you do? Elimination? What do you want to multiply by?
I mean, it has to be negative.
-2.
Doesn't it both?
So my x's cancel and my y's cancel. So I'm left with 0 equals -2. 0 does not equal -2, so it's inconsistent. So what I expect you to write here is no solution and inconsistent. So the technical answer is no solution, but on these I will say to identify any inconsistent systems. So when you get no solution, it is an inconsistent system.
Will we get any that it has the same number on both sides?
Yes, so let's look at one of those.
Those ones, those would be
Alright. Did everybody get that one?
The last one.
So there's only one possibility that we haven't looked at yet. And this is the only thing that's going to be slightly different than last year. Sometimes you might solve it and get like 3 equals 3. And what that means is both equations are for the same line. So last year you just put infinite solutions. This year we're going to be a little more precise because it's not every ordered pair in the world that works, it's just every point on the line itself that works. So let's say I gave you this one. It's a little bit uglier because of the fractions, but we can still deal with it. What could we do? Any ideas?
Like negative.
Times it by 6.
Okay, let me ask you a question. If I were looking at the top, if I wanted to get rid of this denominator, what would we have to multiply by? 3. And that would give it a 1x. If I wanted to turn it into this, then you would have to multiply by 6. So if I have to multiply by a 3 and a 6, 3 times 6 is 18. Let's try multiplying by 18. So 1/3 times 18, that's like 18 divided by 3, so that's 6x. 18 times 1/6, so 18 divided by 6 is 3y. 18 times 2/3, so 18 divided by 3 is 6, times 2 is 12. So when I add, those cancel, these cancel, and these cancel. We get 0 equals 0. That's a true statement. So your directions are going to tell you how to write this. I will say either make x arbitrary or y arbitrary. Okay? So, for instance, when I'm asking you to do an arbitrary variable, I am asking you to write your solutions in terms of that variable. Okay? So if I said that y has to be arbitrary, we can write these points a couple different ways. We can either keep the x variable as x and change our y to something else, or we can keep the y as y and change x to something else. If it says y arbitrary, that means I'm keeping y. So my ordered pairs, y is going to be the same. But you have to figure out something for x in terms of y. So that means I'm going to take this and let's solve for x. So if I wanted to get x by itself, you would add over your 3y. So 3 over negative 6 is negative 1/2 y. Negative 12 divided by negative 6 is positive 2. So my x is negative 1/2 y plus 2. Okay, so we described the ordered pairs, what they're going to look like. When you do that, you will keep one of the variables. If I had said keep x arbitrary, then the x would have still been x, and you would have to go to your equation and solve for y to figure out what to put for the other one. So the only time you're going to have to do that is in those cases where there are infinite solutions like that. And I will specify in the directions which variable to keep. Questions here? Do we need more problems like anything